I can turn it all the way up. You want it a little bit more down?
So now you want to make the recording valuable, we want to have announcements. And
Yeah.
Right? You want to give announcements? You want me to
Okay.
start?
you want to promote the next month's meeting,
Right.
probably some other groups' meetings.
Well, give me 1 second.
Welcome, everyone.
Hello, I'm Barry DeSico. I'm the current president of the Ann Arbor chapter. I'd like to announce our upcoming meetings. We've got meetings scheduled for the last Tuesday in March and the last Tuesday in April. We're looking for presenters, so if you have some sort of statistical talk you'd like to try out on us before you take it to casts of thousands, please let us know. Other useful things in the Michigan SAS Users Group will be having a webinar on Thursday, March 14th. You can just search for Michigan SAS Users Group to find their website and register. Also, the Ann Arbor R Users Group has meetings on the second Thursday of each month. You can find us on Meetup. Look for the Ann Arbor R Users Group. The next presentation will be on causality in R.
Perfect. Now you're going to introduce the speaker.
And now we're going to introduce Brandy Sinco. She's basically been around U of M for 20 years.
27 years.
27, I didn't want to quite say 30. She's basically worked at a variety of places at University of Michigan, doing stats, SAS programming, and helping people. And you can see her bio, little potted bio there on the screen. So welcome, Brandy.
Well, thank you, Barry.
Good job, Barry.
Okay. Got some technical challenges tonight. Everything is going to be fine. Just think positive.
Wonder if we can adjust the camera so it sees you. We want to, let me see if I can. She'll help a little
Let's
bit.
see. We'll try to start up a little bio. My name is Brandy Sinco. I appreciate the opportunity to present and share one of my exciting projects tonight. I work for the Center for Healthcare Outcomes and Policy, also known as CHOP. It's the part of the Department of Surgery, which is probably why we call it CHOP, like, you know, the chopping block surgery. Right here. And you can see my bio, so we're not going to, we're just going to start the presentation.
1 minute while we get you in the screen.
Okay.
So that people at home can see who's talking, and maybe I'm gonna get them dizzy. I think we need, I'm sorry, I can't tilt it back any farther, but that's good enough.
All right.
Okay, all right, thanks, Brandy.
Okay.
Thanks for persevering through the technical difficulties.
Oh,
Thanks for coming a good half hour earlier than we needed that.
anything can happen.
Yes.
The only certain things in life are death, taxes, and unimaginable change. So you have to be ready for anything.
Someone actually had hype too. There are 3 things in life that are certain: death, taxes, and lost data. It was terrible.
All right, thank you.
Okay. Over the years, I've worked on a lot of interesting projects at U of M. Also, you know, worked at Ford for a couple of years at MedStat, Urban Magnetics. Tonight, I'd like to share with you a little adventure I had with trying to figure out how to calculate power for a zero-inflated negative binomial regression. I know that's quite a mouthful, but don't panic. Okay, how in the world this happened? I was just starting my new job at CHOP, and one of my first assignments, so the researchers had submitted an article on zero-inflated negative binomial regression, and the outcome was opioid pills consumed. You know, that's kind of a hot issue. You might hear about that in the news occasionally. And they are comparing 2 methods for performing a colectomy, which is a partial removal of the colon. Hope I'm not grossing anyone out. And they're, especially during dinner, after that. Okay. And they're comparing 2 methods of surgery. One is laparoscopic and the other one is robotic. A laparoscope is a method for doing minimally invasive surgery. And these days, a lot more operations are performed with robots. That's another hot topic in surgical research. And if you want to know more about that, speak to one of the surgeons. I wasn't cut out to be a surgeon. I think I'd be grossed out by doing those kinds of operations. But anyway, I have no problem with, data analysis. This is a way of doing that, helping people who unfortunately need to have those operations. Oh yeah, now the outcome was a count variable, number of pills consumed, and common models for count variables of the Poisson model, which you probably heard about, and then if the distribution has more variance than what you would expect in a Poisson distribution, the negative binomial is an option. And I see heads nodding here. Everyone already, we're all pros. Everyone knows that. And then when the counts have more zeros than you would expect to find in a Poisson distribution or a negative binomial, another option is the zero-inflated version of each of those models. Anyhow, the reviewers for the article questioned whether the authors had enough of power to do zero-inflated negative binomial regression, or just called ZINB for short. We need to find a statistician who knows how to calculate power for that kind of a model. And Brandy's new, doesn't have any projects, so this would be a good way for her to start. Offhand, I don't know how to do that. Yes, I don't know of any option in SAS or Stata or in our package that you could teach power for a ZINB model. We had to move to power by simulation. And that's where the adventure begins. Okay.
Brandy,
Gonna start. Yes.
can you give us a little bit of, I don't really have any background, I mean, zero-inflated negative binomial. Is it too hard to talk about what the inflation is and what other things about that mean? Or is it, I don't want to take you off track.
That's coming with.
Oh, I'm sorry. Okay.
Okay, basically, if you have a zero-inflated model, you make a histogram of the data, you get this huge hump at zero.
Oh.
It's far more than what you'd expect.
Oh, I see.
You have a Poisson distribution look like this, and if you need to do zero inflation, then it looks like, whoa.
Right.
I got
Gotcha.
pictures of histograms.
Okay, I see now.
Stay tuned for. Stop the microphone. Okay, so first we're gonna start with, very basic, 101. What is statistical power? What does it mean to calculate power by simulation? Can you hear me?
Yeah, I'm just checking.
Okay, should I use this microphone? Okay,
Working well.
and then we'll get to your question. We'll have an overview of the Poisson distribution, negative binomial, and zero-inflated models. Now, examples I have tonight are SAS. I primarily use SAS. Sometimes I use R and Stata, but did this project in SAS, and then found a really cool research paper that tells you how to calculate the parameters of the ZINB model from Proc Genmod. So you're in for a real treat. Okay, and then we'll talk about how, if you're doing a simulation, how would you do it at the beginning where you're comparing your actual data with like one simulation? Like, does it make sense? And some people like to just jump in and like run their thousands of simulations and compare it. And I'm doing it really carefully, step by step. I think that's the best approach. Okay, and then we'll run our outcomes model on the simulated data to compute the power. And then for the last step, like, what if you want to look at the power in the presence of the covariance? And for that, I think bootstrapping is the best option. And we'll get to that. Okay. Okay, so everyone probably knows this, but we're just going to start basic and then get more and more exotic. So statistical power means that we have the ability to detect a significant effect when it's present. Like, for example, if you look at the mean difference between two cities, like if it's 5 or 20, or is there no significant difference? And one thing that sort of throws people off at the beginning, that power depends on the minimum amount to detect, the variation in the data and the sample size. And the larger amount that you want to detect, the easier it is, the smaller sample size you need. Some people would expect it to be the opposite, but like if you want to find out what's the difference of the mean temperature between Ann Arbor and Miami Beach, Florida, you don't have to work too hard to find out that, see, there's a difference. We want to compare Ann Arbor and Ypsilanti, then we have to take a much larger sample. You know, if there is any difference in the first place. Okay, or mice in the garage. After I finish, I'm going to feed the cats that I'm babysitting for, and they have much more power to detect mice in the garage by the presence of a chemical. Usually the garage smells fine to me, but the cats who are dying to go out there, they have more power to detect that chemical on the mice, and the mice are in big trouble, by the way. Okay, so that's a little introduction to power. So let's say mu is our parameter of interest. It could be a mean or a variance or a regression coefficient. So the power is the ability to detect a difference in mu, given that the difference is really present, that we're accurately detecting the difference. Okay, so in this project, we're looking at post-operative opioid use between patients who have laparoscopic and robotic colectomies. So the null hypothesis, there's no difference, mu1 is equal to mu2, there's no impact of surgical technique, and the alternative is that one of the techniques is associated with higher opioid use. Okay, so our type 1, studying our type 1 error of alpha, that is the probability that we falsely conclude that there is a difference when there really isn't a difference, that we conclude the alternative hypothesis or the null hypothesis is true. It's also called the observed level of significance. Okay, and the type 1 error is that we conclude that there's a difference when there really isn't. Okay, and our p-values are observed level of significance. And then we get to the type 2 error. Okay, that's where we fail to detect a difference when it really is present, when we conclude that the null hypothesis is true, when in fact the alternative hypothesis of difference is true. And now the power is equal to 1 minus beta. That's the probability that we conclude that the alternative hypothesis is true when there really is a difference. Okay, probability of accurately detecting a difference. Okay, now we do power by simulation. What we do is we create a large number of data sets, typically 1,000 or more, with simulated distributions of the parameter that we're interested in. And then the power is the percent of data sets with statistically significant results. Later in the presentation, I'll show you I create an indicator for, I call it SIG, and then if I just run a frequency distribution, that tells me that the power based on simulation. Okay, and I just made up a simple example. Now here I'm going to have an example where SAS or R and Stata can help, and we can compare the results that we get by using the power procedure in the software with simulation. Okay, so suppose we have two groups. One has a mean of 2 and a standard deviation of 2.5 and 10, and we have another group where we have 20 observations. We have a mean of 1 and we have a standard deviation of 2.25. So how much power do we need to detect a difference in the means of 1 between the groups? So like I said, don't need to do simulation for this. We can use a power procedure. I just want to do this simple example before we dive into the ZINB. So I know that's quite a mouthful. Okay, so in common statistics books, find a formula for the sample size with sigma squared and the z statistics and the minimum detectable level. So if I plug that in, I get an F of 1.235. So that would tell me that I use a pooled t-test instead of assuming that the variances are different. And then if I wanted to get that p-value from SAS, I could use data null and prob F function. Or you could use Stata or R or Python or whatever you like. And this is an example of how you do it in SAS. I'd say 2 sample means test, diffs, Stata weight, assuming that the variances are different. And I give it the standard deviations and gives me the power. Or if I was doing equal variances, I'd say test equals diff. Okay. Now, most important number on this screen is the bottom one. It says power is 0.172. And that tells me if I calculated power by simulation, I should get about 17% significance. It's never going to be exactly the same. So give it a try. So I assumed unequal variances. I ran a simulation. I should get significant differences 17.2% of the time. And if I assumed equal variances, I get it 18.8%, so I'm like say 16 to 20%, to be in the ballpark. This is how I do it, take a data step, set my ends, and then I do a 1,000 reps, and I call the grand normal distribution, and I do it again for the other sample of 20. And then a way that's easy, SAS is really friendly with powered by simulation and also bootstrapping, so we'll see later. So I do is I run Proc t-test, by rep. This is I think is an advantage like using SAS over Stata. The Stata doesn't have all the output capability that SAS has, although it's an excellent software package also. Okay, so I run this by rep, and I output the results for equal variance t-test and then the different variance t-test. This is what the output looks like, huge page. And then I take those data sets, and then I calculate, I call sig variable. One of the outputs here is prob t, or compute sig, and that will be 1 if the p-value for the t-test is less than 0.05, and I do that for equal variance and also for different variance. So if I assume that the variances are equal, I get the power of 20.2% by simulation compared to 18.8 from Proc Power. And then if I assume that the variances are different, I get a power of 17.5 compared to 17.2. So if you're computing power, take a real simple example and then use your software of choice and then compare what you get from the power procedure to what you get from simulation. It's sort of like a sanity check. Okay, now Chuck, now we're getting into your question. Okay, so the Poisson distribution for count data, why is the number of occurrences of event, such as traffic accidents. I hear that the Poisson is used in auto insurance. I'm sure AAA really likes that distribution. And the number of occurrences increases with the area of measure. That's why they charge more car insurance if you have to drive further to work. Okay, then we have the equation over here, f of y given mu, the variance is equal to the mean, and then if we're doing Poisson regression, we have ln y equals x beta. Okay, and then see the variance of the Poisson is also mu, and the negative binomial is an alternative to the Poisson when the variance is larger than mu. Okay, variance of negative binomial is equal to mu plus phi times mu squared, where phi is the scaling factor and the mean is mu, same as Poisson. Okay. And then we get into those zero-inflated models. So we have like a two-step model. Those were proposed by Lambert and Green. We have the citations here. Now, the zero-inflated model is a mixture of the Bernoulli distribution and either the Poisson or the negative binomial. Start with Poisson. So when y is 0, the distribution is like p times logistic, where p is the proportion of zeros, and the plus 1 minus p times Poisson. And when y is greater than 0, the regression is 1 minus p times Poisson. We get a similar equation for the negative binomial, except we substitute Poisson negative binomial for Poisson. Okay, now we have data over here. We have a robotic, laparoscopic colectomies and the number of pills that people are consuming. Overall, we have like 28.6% zeros for all the patients, which is a lot more than we would expect. So if I just look at the data, without a model, I just do, let's say, a Cochrane Armitage test for a trend test, we get p equals 0.01. So using a Proc eyeball, that's kind of the SAS joke. It just means you eyeball the data. It looks like there is a difference, but we have to look at it with a more sophisticated model.
So when you say there's zeros, that's zero number of pills that
Zero
people can.
pills. Yeah.
I see, okay.
Yeah.
And so you didn't expect 30% or 29% of the people to not take any pills. That was,
No, it sounds like a horrible operation.
yeah.
I take the pills. Okay,
Yeah.
Remember I promised to show you a histogram of the zero inflated distribution?
Yes,
Okay,
there it is.
so is that what you'd expect to see from a Poisson or a negative binomial distribution? But a zero inflated, you see these huge zero spikes, you do a histogram. I thought, I'd share the SAS code for that plot. I thought it's cool, it's user friendly. This is an SG panels. You can create a panel of plots. And here I'm paneling, by a variable called lap, where they had laparoscopic or robotic. And it's pretty straightforward and user friendly. So feel free to use it. Now, this is really cool. I'm going to show you how to calculate the ZINB parameters from Proc GenMod. Okay, and I discovered this from an article that I found from SAS Global Forum. I can't take credit for figuring this out all by myself. So the syntax for zero inflated negative binomials, you have your model here. I have pills consumed. I say distribution equals ZINB, and I have another statement for zero model, and then I output the results here. I do it separately for lap is 0, which means robotic, and lap equals 1 equals laparoscopic. This is what the output looks like. It gives me an intercept and a dispersion factor for the negative binomial distribution. And you notice the confidence interval for the dispersion does not include 1, so it tells me that actually it doesn't include 0. It tells me that there is significant over dispersion, and this is for the logistic portion of it. And now we'll get into those cool equations that I promised to share with you. Yeah, so I compute the P for the logistic value, like the probability that it's greater than 0 versus equal to 0. So I get my dispersion factor. I've got a beta 0 from the ZINB model and a beta 0 from zero logistic. And if you look down here, computed parameters, P 0 logistic equals X beta 0 from zero logistic over 1 plus the quantity X beta 0 logistics. So that's kind of intuitive obvious. Remember from Biostat 651, one of the first formulas we learned. And then to get the negative binomial parameters, it's not as intuitive. But we've got negative binomial K, that tells you the trial until you get like the first success. So that's 1 over the dispersion parameter. And then that P for negative binomial is different from the P in the zero logistics. That's the probability that you would get your success after so many trials. And that's 1 over dispersion times X with beta 0 ZINB. And in the article, there's a proof for those equations. All right, it's a really cool article. It talks about using all sorts of count models and how you can take the results of Proc GenMod and get the parameters in the model. And one of the authors is named Sinco, but it's not me.
No kidding.
Yeah. Okay, so now I'm going to try simulating one data set. I said start off slow and then move into the more advanced. Okay. 283 patients had robotic surgery. So I could do a little simulation called stream init. That's the most state-of-the-art method in SAS to do simulations. You would call the stream init function. Okay, and then I'm going from 1 to 283. So I start with a uniform. P uniform is like Brandy uniform from 0 to 1. If what I get is greater than P from zero logistic, then I'm going to assume that I have a negative binomial. And I call that negative binomial function with like NB for for P and for K. Otherwise, I set it to 0, and then I output it. Okay, this is an example of how you could simulate different variables in the data set if you wanted to. Okay, and then you do the same thing for robotic. Put those data sets together. And now I'm going to compare what we get from simulation with the real data. Notice I have that variable to simulate 0 and 1. So if I don't simulate, the mean from the data is 23.5. And if I do the simulation, I get 23.7. Oh, it must be on the right track. I know this is kind of exotic and intimidating. The variation is smaller in the simulation though. And then I compared them with Wilcoxon test. And we got a non-significant p-value, another good sign. So moving further into the data, if you want to compare different variables between simulation and actual, you can use something like Proc Freak and SAS, and you compare it by a simulation variable, whether that's actual or simulated. Pearson chi-square, and then if you're comparing variables that are like ordinal or count, and t-test or Wilcoxon. Okay, now we're ready to go for like 1,000 reps here. And here I go back to my friend GenMod, calculate the parameters for robotic. Here I'm just doing one. Now that I have that one simulation, go to my data set and compute the parameters here. And then I'm going to start doing 1,000 simulations. I'm starting that, so I go from like 1 to 1,000, and then 1 to 183, and I do start with uniform. And then if p is greater than p0 logistic, then I set it to negative binomial, otherwise to 0. Okay. Now I'm going to estimate the parameters for the other type of surgery. Similar approach here.
And these are seed parameters are the ones that came from your original
Yeah,
logistic piece.
yeah. Like what if I had like 1,000 versions of the data set with random variation? Okay, put them together here, and I combine them. I support them by rep, as we have 1,000 reps. You can do more, but I read an article that said that 1,000 is adequate for these simulations. It's a big amount of data. Okay, I put them together. And then this is a SAS specific technique. Have you ever heard of an index in SAS? Yeah. Well, this is great because I'm be running remember we saw that I ran t-test by rep. I'm going to run Proc GenMod by rep. And then each data set that I'm running has like over 500 observations. So putting that index really helps it to run faster. And this is a nice reference for using indices in SAS, if anyone's interested. Okay, so I go back to my friend Proc GenMod, simulates it with 1,000 reps. I have my model for pills consumed, pills prescribed, unadjusted model, and I output the parameters. One has the negative binomial, one's the zero model. And then remember I was talking about you have like a variable for significance. So I take those. I'm looking at the parameter, the beta for lab for surgery type, and the problem chi-square is less than 0.05. My wall is less than 0.05. The lab significance is 1. Otherwise, it's 0. And I do something similar for the zero model. And then we would go to Proc Freak and SAS. Stata and R have their analogs to Proc Freak. I do a table of lab significant, and it tells me if I have an unadjusted model, 78% of the time, the surgery, I have adequate capability to detect a significant difference in surgery type. Okay.
You said you use 2 predictors.
Just pills prescribed and pills.
And lab. It says lab and pills.
Oh, yeah, surgery type and pills consumed.
Yeah.
Because pills consumed is like an offset. I mean, pills prescribed is like an offset. So if someone has more pills, you have to take into account that some patients have more pills prescribed. Okay, so we usually like to have 80% power. So I told Dr. Fu and Dr. Suwanabo, can you get some more patients over here? We're a little shy, 80% power. I said, no, we've recruited all we can. We can't have this go on forever. So just tell the reviewers that we have 78% power. And that's it. And I said, well, what happens if you put in covariance? Well, one thing you could do is just run the same procedure, just have like this is like an example in like Proc Power where you have different variables on the model, but it doesn't take into account the correlation. They're just totally independent. So I don't think that's a real good way of calculating power with covariance. So we turned to our old friend, the bootstrap, which I imagine most people here have heard of.
There's Tib Sharani.
Yeah, our old friends here. So what we do here is take our data set and then calculate, B bootstrap samples. In this case, I did 1,000. And it's pretty easy to do this in SAS. SAS is very friendly for simulations and bootstrapping. You can use proc survey select with method equals URS, which stands for unrestricted random sampling with replacement. So what survey select is, it takes like, the sample, so it picks one observation, and then it puts it back, and then it takes another draw and it picks another observation. And it runs very, very fast, very easy to use. So I did it, by data set for laparoscopic and robotic. And then I combine the data sets. I sort them by repetition. Okay. With index on there, and then I run GenMod on the bootstrap data sets. And then I put into the variables that the investigators were interested in, the age, gender, other variables, and then we output the parameters and look to see whether laparoscopic surgery was still significant. And we got power 72%, and it's not the 80% that we would have hoped for, but it's decent. So the final outcome is they responded to reviewers that we ran the power by simulation and included wrote a little blurb about it. We gave them the exact SAS syntax, and it was accepted for publication in the Annals of Surgery, which in the surgery world is considered a prestigious journal, and everyone was happy. Okay, so just to recap, if you end up doing a simulation, like in your job, I would start off, slow. You might try like a distribution that you're familiar with. Like you might just try like a binary distribution or comparing means to make sure you got the hang of writing the syntax to compare simulated data with regular data. And then compare them with frequencies and means, whatever. And if you happen to use SAS, just about every statistical procedure I know of has like a by option. So you can run it, but you can run like a number of repetitions, and you can run it by rep, or you can run it by bootstrap. And they're user friendly. And then if you want to find out how much power you're getting from your simulation, you would compute a variable that's 1 if the parameter of interest is significant, 0 if it isn't, and then you look at the frequency, proportions of significant results that you get from your simulation. That is powered by simulation. So it's not as magical as some people think it is. It sounds kind of intimidating, think of like you're simulating data and finding out how much power you're in it. But it really makes it, I think, an intuitive sense. So if the distribution of your outcome isn't available in a power procedure and statistical software that you like to use, this is a good option. I think it's a useful tool that every statistician should know how to do.
Mm-hmm. Yeah.
So thanks for listening. If anyone has any questions or.
Thank you.
Yeah.
Just a couple of questions on, because I noticed that your cutoff criteria for determining whether it was success or failure was using the standard chi-square limits of 0.05 and other things, and it made me wonder how much I just in a simulation, if you chose at 0.1, for example, and would you get, because those are somewhat kind of by convention, not hard numbers.
Yeah, it's debatable.
Yeah.
You can definitely do a simulation using whatever level of significance you want. You can use 0.1, use 0.01.
If you did that, do you think your power would get less then, or what? I mean,
I think you have more power.
more power?
Yeah.
More. Okay. Yeah. All right. Yeah.
Yeah. I think that's a great idea. Now, if I do this again, I'll do it for like.
Well, I
0.05, 0.01.
try it. Yeah, and see what it does, because And then on another one, when you were running your I think it might at the later slides. Cause you had said if you needed to do something more, go from n equal 283 to n equal 500, et cetera. And I saw that in I think the survey select or whatever it was, the proc, you had n equals 283.
Yeah.
And then the reps equal 1,000.
Yeah,
And it's just because it's a dumb question. I want to know, is it because you have n equal 283 to represent the same sample size that you had from the beginning in order to?
yeah, that's good. That's why I'm doing bootstrapping. I want to do random sample with replacement with the original data set.
And what if with the original data set, if you said n equal 50, would it only use 50 of those points in the original data set? I see. Okay, got it. All right.
But Brad run says to sample all of them with replacement.
Right. Yeah.
So I have sort of two thoughts to share. Sort of related.
Yeah, please.
So the interest was mainly on, the mean of the number of pills taken.
Yeah.
And the zero group seems to be very informative, right? You notice when you did the kind of trend test.
Yeah.
table,
Oh,
you saw a really strong trend test.
oh,
And so if I was to go straight from that table to a regression, I would have tried to do a logistic outcome for the treatment group.
oh,
Put the ordinal variable for the 0, 1 equal 4 greater than equal to 5 categories you had, and then added the to that model. And see how, what the effect was, what the power was, that ordinal variable for the pill count. But I think that with that logistic regression, at least the unadjusted version would be exactly like the confident trend test. So that was one thought, and I know that you kind of walked into this where the analysis has already been done and so on, but that was just one thought that I had. And then the other thought was that
I'm going to respond to that. I would suggest it to the reviewers that we look at, logistic regression. Let's say when we have like a computed outcome like pills consumed over pills prescribed, it's like y over n. So why not try that model? Does it have to be zero-inflated negative binomial? And they thought, well, it's fine. This is what we submitted to. They're about ready to read.
it's really hard to stir the pot once they've already reviewed it with another analysis. So I get that.
Before you move on to your other point, are you essentially saying that you want to dummy out the zero section and put a dummy variable for that in the regression?
No. So the table she showed with the Concord averages trend test had 3 rows, 2 columns. The columns were treatment group. And so if you were to do a logistic regression model where the outcome is which treatment you are on, 0, 1, the logistic regression on that outcome. And then for the predictor, you have an ordinal variable 0, 1, 2, for which pill group you were in. The beta for that ordinal variable for the pill count group, that would be the same test statistic as the Cochrane trend test. And so then adjusting for other stuff in the model.
Right, and that's.
The easiest way to adjust and see if that association stands up after adjusting.
Got it, yeah.
Her co-authors didn't do that, so it's hard to really, once a paper's been reviewed, it's really hard to, unless they ask for it, change up all the analysis.
Yeah, and this simple table doesn't adjust for pills prescribed. It's just comparing pills consumed between the 2 groups.
So were you thinking of this table? So you have
this
the
table.
ordinal for 3 groups,
Yeah.
and that's what I consider dummy variables, but ordinal, so
the
you have
ordinal,
an indicator for
you
each
have
group.
one beta for the rows, then that is like the trend test. If you just had dummy variables,
Yeah.
that would be like Pearson's chi-square test. But if you put it 0, 1, 2, and just treat it as a continuous,
Right, continuous variable,
one beta,
right,
that would
that's
be
the
like
trend.
a confident arbitrage trend test, unadjusted.
Oh,
So
wow.
you could just add in covariance. So the other thought I had was that, the 0 group is so important here. It's not like they were equal. Laparoscopic, a lot of the trend is is being driven by a lot of people laparoscopic, just not even taking pills.
Yeah, robotic people seem to be taking more, about 10%.
Right, and so when you're talking about mean counts of pills, that zero group is actually quite important, and that
Yeah.
spike that you talk about with the zero-inflated model, you know, that's the difference in the spikes. They're kind of being handled by the zero model.
Yeah,
And so that when you are doing power based on the beta from the main count model that accounts for the excess zeros with the zero model, the beta from the count model is it's kind of weakened a little bit because a lot of the signals from the zeros. Right? So I would think of the zero-inflated negative binomial model as kind of like you have this mixture like
Yeah.
you described, and that some people just aren't susceptible to counts. So a lot of times people will use this model when there are a lot of people who aren't just susceptible to the counts at all. And that you're only interested in inference on the people who are susceptible to the counts. And you want to take, you know, the parts of the model that you aren't susceptible, those are kind of being held by the zero model, and why you have those excess zeros is they're just not susceptible. So almost like it's a nuisance. You know, you're not interested in if the treatment changes counts if they weren't susceptible to getting any count. So
What do you mean by
I'm-
susceptible?
Well, so I use these models when I'm modeling pulmonary exacerbations, right? And you have to be sick enough to get, you know, these bad events.
I see.
If you're not sick enough, then the treatment can't really help you avoid them because you weren't actually
Right.
sick enough. And it's hard to tell who's sick enough until you do the study. So there's a chance of you being susceptible and having bad events. And then there's and being susceptible and having zero events just because you get some zeros.
Some zeros.
And then the zero model part of this deal is sort of modeling what's the probability you're not really susceptible. It's kind of like the intuition. And so in my setting, the covariates that end up in that model that are significant are kind of how sick you are. If your pulmonary function is really good, you're not really that susceptible to getting these exacerbations.
I think they did report the results of the zero model in addition to the negative binomial.
I hope so, because that's really important, but the power might have been hurt because of the signal of the treatment was affecting both the zero model in an important way, not a nuisance way, but an important way. And then amongst those who were pill takers, you were kind of finding a difference in means. So if you focus just on amongst those who are susceptible to being pill takers, whatever that means in this setting, I'm not really sure exactly what that means for this setting. That some people would take zero pills when they were still susceptible to taking pills. It's a little, you know, but see, the power would have caught amongst those who's taking more pills, which treatment group. But the mean pill count, including the zeros, seems to be like a big part of the story. So I think maybe if they reported both models and they would have counted either beta for treatment group and either model as being important. And
I believe they did.
And in your power, did you say if either one of those betas for the treatment group is a significant, we're calling it a significant? Looking your sig variable, did you let it be a 1 for significant if either one of the models for the treatment turned up something?
I reported the power separately for the ZINB, for the negative binomial model and the logistic model.
Okay, I think that's a reasonable way to go about it. I think that another way maybe would be to say if either one of those were significant, you're saying that the counts are different between these two groups. And so, and I don't know, maybe you have to do a Bonferroni if you're gonna say either, because it's like 2 p-values and you have to account for 2. I don't know, I think it's interesting, but this is a situation where the zero counts aren't a nuisance. You know that
They're
people
informative,
do,
yeah.
yeah, they're super informative,
Mhm.
so. It's just really challenging I think it's always challenging to interpret the zero-inflated negative binomial model, even though it's the model to use.
What's the is there a convention for using reporting power in the two-stage models? Would you report that it's significant if either one of the models is
Well, so
significant?
scientifically, for your study, if you mainly wanted to know the difference in the mean counts, there's probably some mixture, there's probably some very complicated formula for the mean of a negative binomial that incorporates both the zero model and the other model. There's probably some formula for the mixture distribution that uses both models to estimate the mean by, by treatment group and make it one test. That's super complicated, right? No one wants to do that just to answer one question from a reviewer. So the next best is probably what you did. And then, this other idea of maybe if either or meets statistical significance at the 0.025 level or something. I think there's not a convention for this situation. I think you did something very reasonable. And a lot of these could have been reasonable, I think. Yeah,
I mean, you better would be report the power for, the negative binomial, the zero model, and then if either one were significant.
yeah, and to maintain overall type 1 error, maybe use the Bonferroni significance, 0.025 instead of 0.05 for each.
And Bonferroni is considered overly conservative.
It totally is, yeah. It totally is. The extra work of figuring out how to do it for the overall mean, that would buy you that sliver of power. But it would be too much work. And it's not what they did either. They didn't do that in the paper. They used the betas from the two models.
Yeah.
So. Yeah,
Well, thanks for your comment.
it's a really interesting situation.
If we had the draft, I would tell you that you're the next presenter. That was some good stuff.
Oh, I might
Good ask.
ask the student.
Yeah, if you have a suggestion, but anyway, back to,
Yeah.
we want to wrap and then offline on that. So that's wonderful, Brandy. She actually said that what you did was reasonable. That's a
Anytime you
joke.
Satisfy the reviewers, I think you've done something pretty good.
Awesome, and congratulations for the publication acceptance.
Thank you.
Yeah.
I have a question, Brandy. Whatever happened to that we're not supposed to do post hoc power calculation anyways? It's pretty much P significance driven. If you didn't find significant result, that means you pretty much were not powered for the effect size that you were looking for. And so, I was, more the response should be looking at the magnitude or the 95% confidence interval around the difference. So the effect size. So do we learn anything from what we go through all these post hoc? We've already done the analysis. We already have the sample size. I don't know. When do we actually push back on reviewers asking for post hoc?
We do bootstrapping, we get a sense of like what potential is available in the data. I mean, I know there's some problems with it.
I've had this question too. It's never a fun question, but it tends to come up when you have a negative study. You had a positive study though, right?
Yeah.
So it's more often that it'll come up with a negative study where someone tries to claim these treatments were equivalent. And then the reviewers say, but what kind of treatment difference were you powered to detect? Because a negative study could mean two things. It could mean you had a very well-powered study that truly showed equivalence, or you had a terribly powered study and you just didn't have any ability or strength in your data to show anything. And that question about power tends to come up to say, how well was your trial designed to rule out an important result? But you had a positive study, so I think they were just being ornery.
I know. You got significant results. What is it? I mean, they're right there. You know you have power for it, so.
But even if you had 50% power, we lucked out, so, you know. I mean, they could have potentially argued that it was moot, but it's, you have to have a lot of kind of confidence that they'll take that response. No.
Great stuff, Brandy. Thank you for sharing.
Yeah.
All right, well, thanks for listening, everyone. Thanks for inviting me, and I look forward to what other people are presenting in later this year.
Okay, let's give a round of applause.
Yeah.